principle of groundwater flow. To understand the behavior of the groundwater flow, the Darcy introduced this experiment. They put the sand in the cylinder. Okay, this is put the sand in this cylinder and put the sand inside. And for the cylinder, the area, cross-section area of this cylinder is this area. It's area A. And they put the flow into this cylinder, the flow in, this flow out, and we can measure the Q from this, and then the inflow is in the point 1, outflow is a point 2. Okay, so based on this, know the area and measure the Q, we can measure the velocity. Q divided by A, so it means average velocity of flow passing through the sand. Okay, this is the sand. And for the length between point 1 and point 2 is the L. Okay. Okay, and we measure the pressure head between 2 points using the piezometer. Is to measure the pressure head between 2 points, and we can estimate the head loss from this difference of the pressure head between 2 points. Okay, based on this experiment, the Darcy found that the average velocity is a function of the inverse proportion, indirect proportion with the head loss. Okay, so it means if the high velocity with a high head loss and inverse proportion to the length, the high length is low velocity. Okay, and make this relationship equal using the introduce the one parameter is k. Okay, and for V is the is a Darcy velocity, and for L is mean the difference of the hydraulic head between 2 points. Okay, and this K is mean the is hydraulic conductivity, so it make the two relationship in two part of equal. Okay, and we can write the equation of the Darcy velocity in terms of the differentiate of dh over dx, and for the negative side is for the driving force is less, because so it gives the negative sign, and if multiply this Darcy velocity with the area, so we can get equation of the Q. Okay. And the next equation of the VE is a seabed velocity. So it's like the average velocity divided by n. So n is mean the velocity. Okay, if we can draw this, for example, this is pi, and put the media inside. Okay, and if the water was passing through this, we have to pass it through the void between the particle. So it means this way, this is a seabed velocity is a real flow velocity passing through the porous media. And the next, if we apply the Bernoulli equation for point 1 and point 2, okay, so we can neglect the velocity head because of the velocity head is very small flow passing through the porous media. And we can get this equation. Head loss is the pressure head plus the static head between 2 points. And once we combine the pressure head and static head, we call the hydraulic head. So the head loss between 2 points means the difference of the hydraulic head between 2 points. More detail about the K. K is depend on the soil texture. Okay, look at the below table. This is soil texture, and K in terms of meter per second. For example, for the coarse sand, K is from 10 power minus 3 to minus 7 meter per second. And even create smaller of the K. And for the soil layer with the K, it doesn't change with the distance. We call the isotopic soil layer. But for the soil layer with if the K is changed with the distance, so we call the isotopic soil layer. And if the K is a function of the position, K is a change with the x, y, z position, so it means we call this soil layer is heterogeneous soil layer. And if the K is constant in space, it doesn't change with the location, so we call the homogeneous K. Okay, so K is the mean. K is show the ability of the porous media or soil to allow the water passing through. The unit of K is in a meter per second, or the length times the time scale, and K is a function of the and soil moisture as well. Okay.